Hey, how are we doing, Pre-Cal 12 students? This is Coach Johnson. Hope you're having a great afternoon, great evening, and we're about ready to get this kicked off here for our test tomorrow. Again, I'm going to go over some questions. Some of them link towards the test both for tomorrow as well as the test for Monday. Remember those things that I mentioned in class? Some of the things I won't necessarily mention here. Remember multiplicity and how it interprets a graph. That's kind of a big deal. Also, some of the questions too, some regarding like, hey, if you have a slant asymptote, can you have a horizontal asymptote? Also, the zeros question on the review, that's an important one as well. And I could kind of show you that one. The one that I was talking about is, show you here. Let me make sure I got it. Thought I was on here. Maybe it was. Oh, yeah. It was this one right here. And so number 4 would be, those questions are good ones just as we analyze that moving forward. Just to kind of get us kicked off here, what I'd like to do is kind of start with a couple of these. And again, if you have my cell 770-757-2240, right now I have that there are no. And so because of that, what I'd like to do is just kind of go through those together the best we possibly can. So let's do this. Let's start with let's go through 3 for sure. I'm going to kind of hit these, and we'll go little by little, all right? We'll definitely come to, let's do number 2 and 3. And remember this one up here. If we have negative 4i, make sure you have 4i as well. A couple things with number 1, make sure you know what linear factorization form is, such as this, okay? This would be more for number 1 here. Excuse me. This is in linear factorization form, but if I told you to get it into standard form, you would have to multiply that out. So make sure you multiply this out to get it into standard form, what it asks for there, okay? All right, let's look at number 2. Here. Now, this one is a good one for tomorrow's test. It's a good one to kind of just anticipate and go through. So let's do this. Let's actually go through it together. Now, we know that we're going to come to synthetic division. One thing to note with synthetic is the fact that, yes, you could do P over Q and try to guess all these, but because it's a calculator section, that really sets us up nicely for how we can actually solve for what these zeros or solutions are. Now, as we keep going. One thing to note is because of the calculator, you're going to need to be very certain that you not only know how to plug this thing in, but you also know how to be able to get it within your window. It's one thing that a lot of people are struggling on that I want to make sure that you can get. So again, if you don't know how to do that, please make sure you know how to do that prior to tomorrow's class. All right. Now, as I keep going, I'm just plugging this thing in and seeing what we get out here. All right, so we're getting it all the way through. Perfect. I'm going to graph it. And when I do, what I look at is I kind of back it up a little bit. Maybe zoom fit would work. But I notice that when I go left bound and right bound, so here's the graph. I can even put this here. It looks something like this. And again, it's not going to be perfect, but it looks something like that. One thing that you need to be sure of is when you do left bound, right bound, that you go to the left of the 0, to the right of the 0, and then guess right on top of it. That's very important for what we're looking at for tomorrow. Just be sure you do that for both of those zeros. When we do that, what we find is that one 0 is at 2, whereas another is at 11. Okay, so we have 2 and negative 11. So we're going to start with 2 first. Now, when we plug this in and we simplify, I think a lot of us understand how we simplify. I never think that that's really been an issue. One thing that has been, though, has been what we do after the fact when we get to this 0. When we know that there's a remainder of 0, that this is a 0 of, or it's a solution of this polynomial here, what do we do now? Well, remember, we go off of what the simplified version is, and we bring the next one in, which is negative 11. Stephen, I think, had a great question in class and asked if it mattered what order we went in. And it really doesn't matter. As long as you do it do it appropriately, Make sure that you do it from the simplified. You'll be fine. Now, once I get this, now I take the signs with it to get x squared plus x plus 3. I try to factor, but notice I can't. So to find the next two, I do negative b, which is negative 1, plus or minus the square root, b squared minus 4, a is 1, and c is 3. And then it's all over 2 times a, or 2 times 1. Now we know this is negative 12, so 1 minus 12 is negative 11. So we get negative 1 plus or minus the square root of negative 11 all over 2. This square root of negative 11, we could actually transform it to where now it's I squared of 11 all over 2. And what we've done now is we've set up two different solutions that are linked with both negative 11 and 2. You could leave this as is, or you could put it as negative 1/2 plus or minus I root 11 over 2. Either of those options would be sufficient. All right, excellent. Now, one other one I'd like to look at is number 3. Now, notice that within this, we have our horizontal, we have our vertical, we have our slant, because they want us to find all of the asymptotes here. They also want us to find the holes if it's applicable. So our first step is the first factor. So can we take anything out? And we notice we actually can on the top to get the following. Okay, got that there. And the bottom, we know pretty easily that it's x plus 5 and x plus 3. Notice at the top two, we can also factor that out to be equal to x on the outside times x plus 5 and x minus 3. So as I look, what can I cancel out? I take out an x plus 5, where the whole would now be at negative 5, comma, and now we're going to look and see what is the y that I'm going to get out from this. Now, notice that since we have a hole here, it can't be an x-intercept and it can't be a VA. So once it's a hole, it can't be anything else. So now we look at it and see, can we have an HA? Well, we notice the degree is higher on the top than the bottom. So we can't have an HA. So we open up our eyes to see, can we have a slant? And since it's 1 degree higher on the top than the bottom, we know that the slant asymptote can occur. So what I do is I take the top out, top down, and I divide it by the bottom. Make sure we put that plus 0 there. That's important. All right, so we're good. So what times x squared gets me x to the third? We know that that's x. So we're going to multiply that out. All right, so we then change the signs. Okay, now we get negative 6x squared. Remember, this cancels. And minus 30x. So what times x squared gets me negative 6x squared? We know that that would be negative 6. So y equals x minus 6 would be my slant asymptote for what I'm looking for on that. All right, coming back to the whole here, we know that our simplified version is x times x minus 3 over x plus 3. Remember, our VA is what makes it undefined, so we set the bottom equal to 0, and we note that x is equal negative 3 is our vertical asymptote. Now for our whole, we plug negative 5 back in to get negative 5 times negative 5 minus 3, which is negative 8, all over negative 5 plus 3, which is negative 2. So simplify, this would be 4, 2, which is negative 1. And what my solution would be for number 3. Okay? All right. This is helpful. I'm going to just back up a little bit because we got all the information here. Let's do this. Let's graph this thing. This by, let's see. Let's do it by, let's find an x and y intercept. So let's find x-intercept, y-intercept, x-intercept 0 and 4, y. So we have 0 equals. So it really takes out the bottom to where now it's x equals 0, x minus 3 equals, so my two x-intercepts 0 and 0. I plug 0 in for x, I end up getting 0 on the top because, again, find y-intercept 0. 0 over 50 should be 0. 0 as well, okay? So we have 3, 0, 0, 0. Equals negative 3. and we have a slant at x minus 6. So we're going to 1, 2, 3, 4, 5, 6. Boom. We're going to rise in 1. Okay, so we're going to have really deep slant asymptote. So something like this. Our two y-intercepts there, perfect. It's on the inside, know that it's something like this. It really probably would be something more like that. But you get the idea. So it looks something along those lines there. To try to test to see what's happening to the left of this, do plug it in for our t-chart. So when I plug -4 back in for this, we get -4 times -7 all over -1. So really, I got -28, which is really down in here. So we're going to have another thing that kind of goes down in this area as well. Probably won't have one like that to graph, but I want to make sure at least you've seen it before. Number 6, we talked about heavily in class, so we could look at that again if you need that tomorrow morning. Number 5, domain of the function. We talked about asymptotes quite a bit, but let's do that again. For VA, HA, and slant, okay? One thing to note is that the VA always determines what my domain is. So as I factor this, I get -x squared, so we're going to pull out a negative. Let me change this up. There we go. And it'll be x squared plus 2x minus 12. So what two numbers multiply get me -12, but when added get me positive 2? We know that would be x. Man, is there anything? I'm trying to think here. I can't think of anything. I don't think there's two factors. So it actually, you can't. So that makes it easy. We know the slant asymptote because it's 1 degree higher on the top than the bottom. It would be 1 higher, so there'd be no horizontal. And the slant 8x into squared minus 2x plus 12. So we would figure that out there and kind of go off of that. All right. On this one, one important thing to kind of keep in mind is that with the slant, make sure that you have equal. Do not include the remainders. At the bottom equal to 0. When we do, we know that x would be equal to -4. Now, as we look at the domain will always ride all of x, except x cannot be equal to -4. That right there would be that we're really focused. It rides off of what the VA is right there, okay? You could also say infinity to -4. You could say that as well. However, this probably would be the easier of the two and probably the better one. All right, let's keep. Look at 2 would be maybe number 8. Could be focusing on that. Number 7, just a couple things to note. Remember, 7 is P over the factors of P would be 18, where the factors of the bottom would be of 1. So 18 would plus 3 plus or minus 6 plus or minus 18 plus or minus 9. But they also say that 9 and 18 are not there. So that means that if -3 is, we can use -3 into synthetic here, okay, into synthetic here. And then we could go either of these 4 here, plug one of those in to then simplify even further, all right? All right, let's look at this one down below. All right, again, same pattern, VA, HA, SA, whole, x-intercept, and y-intercept, okay? I always like to put my coordinate for what I'm looking for. Horizontal is y equals, slant is y equals, VA is x equals, all right? So now look at the top. Degree of the top is 2, degree of the bottom is 1. So we know that we would really have none for our horizontal. We also know that we could divide 2x squared plus 2x minus 3 in, or we could go x plus 3 in for it. So what times x gets me 2x squared? I think that's 2x. So we distribute out, change the sign. And once I get to this point, kind of downhill, because now we got negative 4x minus 3. What times x gets me negative 4x? It's negative 4. So we could stop to say 2x minus 4 would be my slant asymptote. Now to get the VA, we set the bottom equal to 0 to get negative 3 for our VA. So let's see what we have now. Okay, let's see. All right, 2x minus 4, so we have negative 4. Rise 2, run 1. Rise 2, run 1. To where what I have now is a line that goes straight through, up and down. And really, that should be a slant asymptote. So I'm going to put a little eraser to it here. All right, let me go get little dots there. There we go. All right, good. So x equals negative 3. We'll say this again here. Now for our hole, is there anything that we can factor out on top? Well, we can try to figure it out here. Let's see, 2x and x. 2 give me negative 3. Going out to get me 2. But that incorporates the 2x and x. So that's kind of a fun. Can't think of anything. I could be wrong, but I do not think that I could factor it, meaning that there is a hole for our hole. Could set y equal to 0, so we'd have 0 equals this, which throws out the bottom, so we can use quadratic formula on top. But in class, so we would not have any x-intercepts. We'd actually have none there because the top would be imaginary. We said here. Now the y-intercept, which is negative 1, so that means that 0, negative 1, that would be my solution. Or we know that it should follow the similar format there. If that one's on the inside, we also know the one down on the hard to see here should both will go either. We'll have one go either way. And so just a kind of a reminder on that. All right. To do P over Q. Again, remember P would be the 2 in this case, negative 2 either way. Would be minus 2 for the possible zeros. Bottoms plus or minus 1, plus or minus 3. So each part goes with possible zeros. 1, 2, 1/3, 2/3. Either any of these 4 right here are sufficient for what we could try for zeros on number 10. Asymptotes and holds, I think we pretty much hit on that pretty good. Just remember that in some of these, and even on this one, I had forgotten now that I think about it. You know, this one had a hole at negative 5, 20, which would be way down here. Just remember to graph those holes as well and be able to graph them just like you did on the test or the quiz rather, last week, all right? All right, so, all right, let's see. Okay, perfect. So one thing to really note on number 9 is that if I have 4i as a 0, a lot of people struggled on this. First of all, make sure that you fill in the appropriate spots for the highest degree. So 1, 0, 13, 0, negative 48. Bring down the 1, multiply to get 4i, add to get 4i, multiply to get 16i squared, or negative 16. And so again, all we're doing right now is trying to simplify a little bit, see if we can get it simplified down. So once I get to here, since I got a 0, if I have 4i, remember there's a rule where you have to have its conjugate, which was negative 4i. So we bring down the first one. 1 times negative 4i is negative 4i. This is 0. Negative 3. Multiply, and you should get 12i, or a negative or positive 12i, which should be 0. So now I've got x squared minus 3. We can then set that equal to 0 and solve. Sometimes you can factor, sometimes you might have to use a quad solve there. But I add 3, and then I take the square root of both to where x is equal to plus or minus the square root of 3. And that will go along with 4i and negative 4i. Okay? All right. Awesome. Fantastic. Hey, hopefully you're able to connect here. I'm going to do this. I'm going to pause for just a second because I am going to come to number 13. It's a good one there. Let me check this out and make sure all is okay. Hold tight. Just want to make sure, try to kind of get this connection, make sure that it's rolling here. You're able to connect here. I'm going to do this. I'm going to pause for just a second. Awesome. Yes, I am okay. All right. So continuing forward. Again, Makai, I hear you out there. We're going to continue on these. We're going to go to the next one. Actually, this will be our last group here. Number 13, we're going to hit on. In fact, let's do this. Let's graph. I like that. Let's graph 13. And let's identify 12. Okay? Identify 12. So let's find x and y intercepts for number 12. And let's also find the holes for number 12. And then we'll finish off with number 13. Now on the top, we're going to pull out a 3, leaving us with x minus 5 down below. Also, as you look at the bottom here, this bottom part, we could pull out an x, and when we do that, we get x squared minus x minus 20, okay? Which, if I were to factor, would be x times x minus 5 times x plus 4. Really what we're doing now is we're simplifying and taking out that 5 because of the x minus 5. Since we can cancel that out, we know that a 5 is going to be our whole. Note, if it's a whole, you cannot have it as an x-intercept, and you cannot have it as a VA. It's a big, big thing. So my simplified version is 3 over x times x plus 4 right there. Now, since the degree is higher on the bottom than the top, we automatically note that the horizontal is y equals 0. However, we're only looking for x and y intercepts. That's it. So for instance, if we're looking for the x-intercept, we could plug 0 in for y. So what we could do is really take away this, because I could multiply it on both sides, which gets me 0. Really, we set the top equal to 0. We notice that there is no x-intercept because 0 equals 3 does not make sense. We then go back and notice that 3 over x times x plus 4, we could look at this and actually plug 0 in for x to get what the y is. You could absolutely do that. However, you could also plug in 0 to the top over on the number over on 12 over the top of it. Either way, if I plug 0 in for x, we should note that in both cases there will be intercepts for y, because I wrote times 4, getting 0, 3 over 0 is undefined, which is none. Please don't put undefined on the test. Please put none. That's really the correct answer there, and make sure you put it in the regular point form. Now, to find what the y is of the whole, we're going to plug 5 back in. When we do that, we should get 5 times 9 on the bottom, which would be 3 over 45. That right there would be the only thing I could find that they asked for, and that's the whole at 5, 3/45. Okay? All right, last but not least, we're going to do this one for Micaiah. That's number 13. What I'm going to do is this, as I go through this, we are going to solve, and then we're going to put it on the graph to see if that makes, hopefully that may help you, maybe doing it a little bit different. All right. So as I look at number 13, we want to put it in the right form to where it's from standard form, from the highest degree down. Okay. So on the top, as I factor, I notice that when I factor, I have x plus 5 and x minus 3. On the bottom, when I factor, I'll have x minus 4 times x minus 3. Now, after I do that, we have the slant, horizontal, VA. I always put all of these down. Holes, x, y intercepts. All right, I have all of these. Okay. Now, as I notice, the degree's the same at top as it is bottom, so we have none for the slant. We do have 1 for the horizontal because when we divide, we get a value of 1. X squared over x squared is 1. If this was a 2, it would be 2, right? Because we have to include that there. The VA, well, first of all, we know that we could cancel out the x minus 3's, leaving us with the whole at 3. Notice it cannot be a VA, even though it's on the bottom. I note that my new form is now x plus 5 over x minus 4. So what I want to do now is I want to set the bottom equal to 0. So when I do that, set it equal to 0, I get now x is equal to positive 4. I then plug 3 back in for x to get 8 over negative 1, which would be negative 8 as the y with 3 as the x. Now, as far as the x and y intercept, we're going to plug 0 in for y to where when we multiply by x minus 4, we're really setting the top equal to 0. So x plus 5 equals 0 gets me a value of negative 5 for x. So we should have negative 5, 0. The next thing we note is that when I plug 0 in for x, I get out what my y-intercept is. So 0 plus 5 on the top would be 5. 0 minus 4 is negative 4. So negative 5/4 will be my value for my y-intercept. Okay? So I have all of this mess here to where now I have y equals positive 1. Okay? Let's do this one right here. Y equals positive 1. X is equal to 4. I note that the hole is at 3, negative 8. So that's really far down there. So I'm going to put a hole there. Negative 5, 0 is a x-intercept. And 0, negative 5/4 is a y-intercept. So really what I have is this. This will continue. Again, it'll keep approaching that y or that vertical asymptote, but it can never cross. Same thing with the horizontal. Now, normally it's going to go to this other side, but just to be sure, let's make sure we plug it in. So we're going to plug in a value to the right of this, which would be like 5. So 5 times 5 is 10. 5 minus 4 is 1. So 10 would be it. So 5, 10. 1, 2, 3, 4, 5. 10 would be all the way up here. So literally the graph should look something like that right there. Okay, and again, it's approaching that vertical as well as the horizontal. Okay, and that would be my solution. Yeah, and I hope this has been helpful for y'all. If you have more questions, come on in tomorrow morning. I'll be more than happy to communicate with you regarding that. And other than that, happy studying tonight. Care about y'all, love y'all, and look forward to touching base with y'all tomorrow before the test. Remember, there's 5 questions. There'll be 3 of these, 3 graphing ones, not maybe perfect like this, but 3 graphing. And then there'll be 2 that will be more like what was at the beginning there. All right. Thank you so much. Have a fantastic day, and we'll see y'all tomorrow. Bye now.